Okay, we have a series, and we're going to use a comparison test in order to see if this converges or diverges. We're going to use a comparison test because we know something about 1 over n to the p. We know that if p is greater than 1, then this is going to converge. This is going to converge. If it's less than or equal to 1, then it's going to diverge. And that makes sense because that's an exponent. So if your exponent is getting larger and larger and larger, this entire thing is going to get smaller and smaller and smaller. So it makes intuitive sense that this would converge and that this would diverge. So with this one, how can we get it into this form? This is the form we want. So let's look at the numerator. We have a 1. How do we make this go to 1? Well, we have the natural log of k, which is the same thing as log base e of k. So what would we let k be in order to make this entire thing become 1? We would let k be e, because now we have log base e of e, and that is 1. This equals 1. So now we could get it in that form, where it's much closer to this, and that's so we could do our comparison test and find out if this is less than or if it's greater than whatever we get over here. So let's make this replacement. But we have to be very, we stand no choice but to be approximate here, or to be approximate, because remember, we can't plug in irrational numbers into that. We can't plug in 2.7181 and so on that e represents. But 3 is close enough, right? 3 is close enough because e is 2.7181 and so on. That's close enough to 3. So we could start this at 3 so that that becomes 1. Because remember, this is k, right? So we're plugging in 3 for k, and that would make it go to 1. Not really, but approximately. So that's what I put an n here. So given that, now we can make our comparison, because here we just have k. We just have k, and this is to the power of 1. So we know what p is. That is p. P is 1, and based on our situation here, we know that this is going to diverge, because it's certainly not greater than 1. 1 is less than or equal to 1. It is equal to 1, so it diverges. So we know that this thing here diverges, and we can make this comparison even though this started at 1, and this one started at 3, because it doesn't really make a difference. I mean, think about it. We're talking about infinite sums. If you just start your sum, 2 numbers later, you're still going to infinity, and they're the same kind of infinity. You're not. It's not going to make a difference whatsoever. So now we can make this comparison. Is this greater than or less than that one? Well, it's clearly greater than, because as we plug in numbers from here, they go not only in the denominator, which is the same, but they also go in the numerator. And the natural log of something, of these growing integers, is obviously going to get larger and larger and larger, whereas over there you just have 1. So this is clearly larger. So if this is larger than something which diverges, then this must diverge. So that's how you do it.